In this video, we're going to work on learning target 2 as well as learning target 3. We're going to learn how to solve an equation, and we're also going to learn how to justify the steps in solving a linear equation. Okay, so the justification that we're going to talk about is going to come from our last section with those different properties that we were talking about. So I want you to follow along and fill in each box as we go. We're going to talk about the different steps that you need to take to solve a linear equation. So we're going to start with step 1, eliminating parentheses or distribute. So anytime you see an equation that has parentheses, the very first thing you're going to do is use the distributive property. Okay, so for example, just to remind you, if you see something like this, you're going to take 3 times x, you're going to take 3 times 4, added together, and you'll get 3x plus 12. Okay, so not every problem is going to have parentheses, but if it does, that's your step 1. Step 2 is to, on an individual side, is to add or subtract. Maybe we should write combine. Combine like terms on each side. Okay, so if they're on the same side, that's what you're going to do next. So 2x and 3x are on the same side of the equal sign is what we're talking about. So we're going to start by combining those together. Okay, so we're going to combine 2x plus 3x. Doesn't matter that they're not right next to each other. We know that they are alike because they both have an x to the first power. So we're going to combine 2x plus 3x equals 5x plus 4 equals 20. Okay, so that's just if you have an x or like terms on one side of the equation, you're going to get those together next. Okay, step 3 is to make sure the variable is only on one side. So that means if they're on different sides of the equation, okay, we're going to have to make sure that the variable is only on one side. This is where that addition property of equality comes in. Okay. And what I'm going to do is I'm going to eliminate it from 2x from this side. Usually when I have variables on each side, I'm going to take the smaller one to move. So in this case, between 6x and 2x is smaller. So I'm going to take 2x, and to get rid of it from this side, I'm going to minus 2x so that it's gone. Because 2x minus 2x is going to give us 0 x's. Okay? And because of that addition property of equality, to keep the sides equal, I have to also subtract 2x from this side. So I'm just going to write it up here, minus 2x. Okay? So really what this looks like is 6x plus 4 minus 2x equals 2x minus 2x. Now, typically we won't write this step out. It's okay to just kind of add it in there with the original equation, but I just wanted to write it out so that you could see it this time. Okay, so what you're going to be left with after that is 0 on this side. 0 x's, nothing left. Okay, you're going to combine 6x minus 2x, that's 4x, plus 4 equals 0. Okay. Step 4 is to eliminate the constant term. So the constant is the term without the variable. Okay. So this will either be the opposite of addition or subtraction. So just like we were talking about in the last one, I want to get rid of this constant from this side. Okay. So what I'm going to do is I'm going to subtract 7. Okay. From each side. I can, as long as I minus 7 from both sides, we're okay. Okay. That's going to cancel itself out. We're going to be left with 3x equals 19 minus 7 is 12. Okay. And then that leaves us with our very last step is eliminate the coefficient of x. So that the coefficient is whatever is out in front of the x. This will be the opposite of multiplication and division. So in this case it's 3 times x. So to get rid of it, I'm going to divide by 3. We can divide both sides by 3 and it'll keep it equal. 3 divided by 3 is going to cancel itself out to become 1x, which we just write 1x is the same as just x, okay? So we're just going to write x equals, and we're going to take 12 divided by 3 equals 4. And maybe you know when you look at it that 3x equals 12, that means x has to be 4, that's fine. But for now, let's go ahead and write out those steps just to keep everything clear. It's not going to be that much extra time for you to just write out these steps, because really this is about the process, and we really need to see your process of solving. Okay, I just want to show you one more example on this one where maybe it's a division type problem. So we might have something like this: x divided by 7 equals 4. Okay, so we're going to do the opposite. We're going to multiply both sides times 7, because then, once again, these will cancel out and we'll get that x equals 28. Okay? So that's what that would look like. All right, so we're going to talk about what it would look like to justify each step. Okay? So we can see that we can skip step 1 because there's no parentheses. So step 2 is combining terms on each individual side. There's no like terms on the left, there's no like terms on the right. So I know I got to go to step 3, which is to get the terms all on one side. Between a 5x and a negative 6x, the negative 6x is the smaller one. So I'm going to get rid of a negative 6x. And I know that to get rid of a negative 6x, I can add a positive 6x. So I'm going to do that to both sides here. I'm going to just go all in one step. Oh, what? I got to justify. Okay, so I got to justify my steps. So why do I add 6x to each side? Well, I know that if I add the same thing to each side, it's going to stay equal, and that's the addition property. I don't mind if you abbreviate, addition property of equality. Okay, then next step, I'm going to combine like terms. So 5x plus 6x is 11x minus 6 equals 16, because these two are going to cancel out. So that step was combine like terms. Okay? See how every single step is laid out. Every single step along the way. I don't leave anything in my head. I make sure that I write down every single step. That's what we want you to do for a little while here. Okay? Next thing we're going to do is we're going to eliminate that constant. Okay? So the opposite of minus 6 is going to add 6 to each side. So that's, once again, that's that addition property of equality from the learning target 1. Okay? So add 6 to both sides. That means this is going to cancel out. Here I'll be left with 11x equals 16 plus 6 is 22. Okay? Now I need to eliminate the coefficient of x. This is 11 times x, so I need to divide by 11. So this is the division property of equality. Because I can divide both sides by 11, I know it's going to stay the same. And I'll have that x equals 2. And then I'm done. Next one, got parentheses there. That means the very first thing I need to do, distribute. Okay, so 4x minus 8x plus 8 equals 8. So I'm going to go ahead and do that multiplication in my head. 8 times x is 8x. 8 times 1 is 8. That's the distributive property. Okay? Next thing I need to do, step 2, is combining terms on each side of the equation. So there's no like terms on the right, but there is like terms on the left. Now you got to be careful. This is a subtraction this time. And it's 4 minus 8. It's not 8x minus 4x. That's totally different. You need to be really careful here. 8 minus 4 is totally different than 4 minus 8. So I'm going to take 4x minus 8x. That's going to give me negative 4x plus 8 equals 8. That's combining like terms. Okay? Next thing I need to do is eliminate that constant. So plus 8 means I'm going to subtract 8 from both sides. That's that addition property. Oh, not addition, subtraction. Addition property of equality. Okay? And then the last thing I'm going to do, we're left with negative 4x equals 0. Last thing I'm going to do is take that negative 4 times x and eliminate that by dividing by negative 4. The division property of equality. Change this to subtraction. Sorry about that. And I'll get that x equals 0, and I'm done. Okay, now we need to talk about two special cases. So I'm going to go ahead and solve through these and show you what's going to happen. So starting with distributing, I don't need to justify in this case. Only justify your answers if we ask you to. Okay? Start by distributing. I get 2x plus 8 minus 5 equals 2x plus 3. I'm going to combine like terms on each side first. So in this case, the only like terms are 8 minus 5. So I'm going to get 2x plus 3 equals 2x plus 3. Okay? And what you see already, what you should see already, is that the sides are exactly the same. So maybe you would have to do a little bit more. Maybe you subtracted 3 and you figured out that 2x equals 2x, right? So when this happens, when you get exactly the same thing on both sides, doesn't matter what x equals, they're going to be the same. X could be 1, it could be 2, it could be 3. So there's not going to be just one answer for x. So when you get the same thing on both sides, what you're going to have is you're going to have that there are infinite solutions. That means there are many solutions that x could be. There's infinite number, okay? Now a different case here, I'm going to go ahead and combine like terms on each side. So 4m minus m, and remember this is like 1m. It's going to give me 3m plus 1 equals 3m plus 9. Now if I combine the terms on each side, that means I'm going to subtract 3m from this side, subtract 3m from this side. Those are the same. They're going to eliminate on both sides. You're going to end up with 1 equals 9. So is it possible for 3m plus 1 to be the same as 3m plus 9? No. 1 cannot equal 9. So that means that there are no solutions in this case. All right? Okay. So before class, you're going to write your own equation. Okay? You're going to have to be a little bit thoughtful about this because it needs to have a solvable answer, or it needs to come out as infinite solutions or no solutions. Okay? So make sure that you solve that equation before you come to class. Make sure that it's solvable and that it works out so that you can check your partner's work. So make an equation, solve it out, and then we're going to switch equations with our partner once you get to class.